We're ready to start. Welcome to the PhD in Educational Neuroscience Distinguished Lecture Series hosted here at Gallaudet University. Welcome to those here in the room and to those live streaming from across the country. This lecture series aims to honor world-renowned scientists in the fields of psychology, education, cognitive sciences, and neuroscience. These different fields and all the interdisciplinary fields in between contribute to the new and growing field of educational neuroscience. We want to understand the human mind and more so how the human learning mechanisms in their cognitive and neural dimensions. This year's Distinguished Lecture Series theme is Breaking Down Barriers. With our distinguished lectures in the heart of DC, we want to build bridges across fields and across scientific communities here in the area and across the nation. Everyone is welcome to attend, and we hope that many more can actually enjoy these presentations by streaming these presentations. I know there's a lot of people today. I've received numerous emails for this presentation. Dr. Meltzoff is the first of our spring lecturers. We are delighted and honored to have Dr. Meltzoff accept our invitations. Thank you very much in the name of everyone for being here. Professor of Psychology at the University of Washington, he has received his bachelor degrees from Harvard and his PhD from Oxford University under the supervision of one of the pioneers of cognitive psychology, Dr. Jerome Bruner. He currently is the co-director of the University of Washington Institute for Learning and Brain Sciences and director of the Infant and Child Studies Lab. Dr. Meltzoff has received numerous grants from NICHD, NSF, the James McDonald Foundation, just to name a few. Has been recognized through several national and international awards for his outstanding science. In the unlikely case you should not know, Dr. Meltzoff is internationally recognized for his research on infants and child social development by conceptualizing novel methods and technologies for studying infants and children's cognition. He has revolutionized our understanding of how children perceive others and others' intentions. He has unveiled the core skills for later social development, and his findings have had high impact on theories of social cognitive development, learning, and language acquisition. Today, we will learn more about Dr. Meltzoff's like me developmental theory and how it is foundational for human social cognitive development. The title of the talk, Mind, Brains, and How Children Learn from Infancy to Society. And without more ado, please join me in welcoming Dr. Meltzoff.
Thank you, everybody. I'm very happy to be here. I've already had a good day. Laura and Petito greeted me at where I was staying and walked me around campus. We had a great breakfast together. Thank you very much, Laura. And I hope everybody here knows how much Laura and, I don't know if that was me, and Tom Allen have represented Gallaudet very well as part of the NSF Science of Learning Center group that they funded, VL2. I wonder, there's not supposed to be anything electronic here, so that's odd. Maybe I'll stand back from here, but that could just be a happenstance. VL2 and Gallaudet were part of NSF Science of Learning Center group. NSF put a lot of funding into understanding the science of learning, and Gallaudet and the idea of a visual language has added greatly to that enterprise. I'm part of a Science of Learning group in the state of Washington at the University of Washington, where we look at learning in formal and informal learning environments. That means in school and out of school. And I've tended to focus on early learning. So I want to talk a little bit about the research program that I've been doing, and I've picked out some elements that I think might be of interest to people here in the room. I'm going to cover many topics, and so would intend to do it somewhat quickly on each of them. First thing I'm going to talk about is the representation of action in young infants, and then talk about a theory that I've developed about social development in human children called the like-me framework. And this is the idea that children, even before they have language, are very interested in what entities out in the world are like me and self-other mapping in ways that I'll develop. Then I'll talk about developmental social cognitive neuroscience, especially using EEG that's done with my colleague Peter Marshall, who's locally here at Temple. Third, I want to talk about children's understanding of gaze and joint attention. And when I get there, I'll talk about some new research that we've done with deaf children in this regard. Next, talk about emotions and how perceiving other people's emotions affect young children's learning. And then go up in age to elementary school children to talk about stereotypes that children begin to develop about other people. Since this lecture series has to do with breaking down barriers and stereotypes that human beings have about many other social groups is one of the things that erects barriers between people and social groups, I thought today that introducing some of this work on stereotypes would be of interest to you, and I'll try to show how that's connected to the infancy work through theory, actually through the like-me theory that I'll develop, and then I'll elaborate that in the last section. So it's an ambitious agenda. I'll go somewhat quickly through things, and to begin with, I want to talk about imitation and the representation of action. As I met with people in offices, I recognized that there are many people here interested in the representation of action, not surprisingly because using visual language does have to do with the perception of human action, although clearly there's a linguistic overlay and interpretation and neural substrate that deals with those movements and actions. There's still how the brain represents action is of interest, and I have tended to study that in hearing infants, but children prior to the time that they're acquiring language. So it's taught us some fundamental things about how the human brain processes language. And one of the ways I look at that is perception production mapping that is tested through infants' imitation of actions they see other people do. And because people are interested in action and child development here, I thought I'd show a very short movie. It doesn't have any sound, but I will talk over this movie. It's about 45 seconds, and it's a young child in our laboratory done for one of those Scientific American type shows that appear on television. And so host of that show was Alan Alda, who's a movie star. You'll notice him in the movie. And I just want to show what imitation looks like before I develop some theories about action. So here's a young baby in our lab who's watching an arbitrary gesture of putting beads in a cup. We do not give any linguistic description of what to do, just give the baby the materials. And then the baby does the same action and is quite happy of having achieved the goal. Then we take a cup, turn it over, and squash it with a hand. The baby looks at the cup and at the person, and then does the same thing they have seen the adult do without any linguistic support. Then we have another gesture of pulling apart a toy. The baby looks at the person and the object, and boom, pulls apart the toy. And the last one is we want to make sure the baby was learning novel gestures that they don't do. And so Alan Alda touched this object with his head. Do you want to turn? And the baby does the same thing. So I show that movie just to show the power of imitative learning in young children before there is linguistic instruction. We are actually instructing or teaching our children, whether we know it or not, about the cultural customs and rituals out in the social world but also how to work objects and devices in the world, how to operate on things you see. Children want to type on your computer keyboard. That's not through reinforcement learning that they do that. As a matter of fact, parents often, when the child types on the keyboard and ruins their manuscript, says, honey, can you not type? Can you not touch the keyboard? So the parent's busy saying no, but as soon as the parent walks away, the child wants to go do this because they're imitating what they see the adult do. Or a child's favorite thing might be to dive into the mother's purse and take out a lipstick and smear it on the face. The reason they do that is they see that the mother does that and they want to do it. Again, not through reinforcement, because the mother might have said, honey, don't use my lipstick, but as soon as she turns the back, the child wants to do it. So children are observing what we do, and the interesting theoretical issue is they're able to do perception-production mapping from observation of human action to the production of human action, and that, of course, raises interesting issues for social psychology, developmental psychology, and for neuroscience. And so some of you might know this work. I was interested to begin with about how early on imitation begins, and we published a paper and a whole series of papers with young babies showing that if your gestures are simple enough, such as facial gestures, sticking out your tongue or opening and closing your mouth, pursing your lips, or moving your fingers, babies at birth can imitate these actions. And so I have argued that babies are able to make this translation from the observation of human action to their own production and can do that at the beginning of life. That is not something that's learned by association, not something that's learned by reinforcement, but rather that the babies come into the world being able to observe human action and map it onto their own body. And I've gone a little further and developed this into a theory that I call the like-me developmental framework. And this idea is that even for young babies in the first months of life, one of their major projects is to look out there in the world and see other things that are moving like I feel myself to move. Now, any arbitrary movement in the visual world can attract the baby's attention. Babies can be attracted by a mobile moving, or in the hospital maybe by the swinging stethoscope that's on the doctor's neck, or when they're a little older, see the trees outside move or the cars move. And their visual attention will be attracted to those things. But people are special. And I think people are special not only because they have a certain morphology, like faces, which can attract attention, but also because they move in particular ways, including facial movements. And I believe that the baby is able to see those movements and recognize, aha, there is something out there moving like me. There is something out there that I can map the identity between what I see and what I feel myself doing. And I think this has profound implications. It's an action representation basis for a lot of social development, a lot of connection between self and other. But I mentioned that babies don't just imitate simple body actions like mouth opening and tongue protrusion, but that they imitate actions you do on object. And here's that pull-apart toy where we did a study in 1999. The reason it's an odd room is we wanted to show the baby a series of actions. There were 5 different objects, but the first one I'm showing here is just pulling apart this toy. The mother wears a blindfold so she doesn't know what the adult is doing. The baby's in an odd surround, a polka dot room. And the reason we did this is we want to see if babies could learn how to use this object, commit it to memory, and then transport that memory to another room, another environment. And that's all important for using imitation as a mechanism for learning in the real world, because you won't always want to use the action in the same context or environment where you learned it. The same as a sign later. It wouldn't be that if your mother taught you the sign or you learned the sign in the living room, that you would not be able to produce it in the kitchen or the bedroom. It has to be that it transports to different contexts with you. So we tested this experimentally by showing the baby a new arbitrary act. Babies didn't know what to do with this toy. If you gave it to them in baseline group, which of course we had, babies would take the dumbbell and pound it on the table or put it in their mouth. But we showed them that you could pull it apart, and then we had a series of delays. These are independent groups. One group were given the toys at 3 minutes. Another group were, they saw the actions and went home and came in a week later. And another group saw the actions, came home, back to the lab 4 weeks later, a month later. Importantly, they never handled the objects when we showed it to them. They only saw the actions through observation. I think this is also relevant to learning ASL because it's not always the case that parents use hand molding or whatever. Babies can see what the adult is doing, commit that to memory, transport it to a new context, and use it at another point in time. So there's some deferred ability to recreate the gesture. Now, I'm very well aware that ASL is symbolic and there's a representational, referential aspect that Laura talks a lot about. It's symbolic. It's not the same as imitating gestures. But I'm saying that some of the substrate to be able to learn by observation only, and then the ability to commit that to memory and use it in other contexts, those things are relevant to explore. The long and short of it is that the blue squares are the babies if they saw the action and then reproduced it in the same context, the polka dot room. That's the blue boxes. The red ones are if they change context. You can see that the curve is very similar. Here's the baseline group about what happens, groups, what happens if you give the baby the objects immediately or after various delays. So that's what they do spontaneously. Each of these differences are significant in each of those delays. So babies as young as 12 months, which is this age, are able to learn from observation and remember what you showed them a month later without having handled the objects. We also wanted to test whether babies, or prove that babies could learn completely novel acts through observation. And so instead of only having the pull toy, we did a novel action of this flat panel, which I showed you before, and we showed the baby had to lean forward and touch on the forehead with that panel. The baby simply observed it. They didn't handle the panel at all. In this particular study, they observed it and went home for a week, came back to the lab, and we slid the panel across the table. And this series of slides shows what happens. This is a 14-month-old boy. When we give them the panel, whoops, I'll go back here. The baby's looking at the adult. We give them the panel. The baby looks down at the panel and then looks up and smiles. So the baby committed this to memory having only observed what the adult did and was able to imitate after a delay. I think that's relevant for social and cognitive development. So I want to move to part 2, which is done with my collaborator Peter Marshall and Joni Saby, who is his postdoc at Temple University. They're experts in EEG, and we began collaborating to what is the neural correlates of imitation, how are babies able to do it, and have published an interesting series of papers. These are 3 references. This is cut off, this 2014 in Royal Society, Developmental Science 2011. The basic paradigm here is the baby wears an EEG cap and the adult shows an action and the baby can perform an action, and we're taking EEG measurements during this time. And measurements are taken in frontal region, central, parietal, and occipital, but we are expecting our responses, chief responses, to be in the central region by measuring mu rhythm desynchronization, which you probably all have heard of. And the results show, as expected, that when babies perform an action, there's significant mu rhythm desynchronization in the expected area, the central region. This is what happens when they're executing the action, and in the publication we show a similar graph of what happens when they're simply observing the action. And we show similar mu rhythm desynchronization in the central region, not when they're doing the action, but simply when they're watching somebody else do it. So this is helping us explore the neural correlates of imitation. Socially, a very relevant thing is not just that babies can observe what you do and imitate, but that parents tend to reflect back to their parents reflect back to their children what the children are doing. In other words, parents imitate their children as well as children imitate their parents. And that's a very important social signal. So we want to look at how the brain responded to being imitated. It's a social signal in the sense that for any of you who are parents or aunts or uncles, if a child comes up in front of you and moves this piece of paper, and the child's a 12-month-old, you can't talk to the child, often what you would do is say, "Oh, honey, do you want to play a sliding game?" And then the baby does that back. And you say, "That's right, we can slide this." You do that back. That's a common interaction. You repeat things that the child does. We want to know why that was special to babies. And so we had an adult imitate what the baby did or did an action that was non-imitative in an experimental setting. And we found out that there was significantly more mu rhythm desynchronization when the adult matched or imitated the action that the baby had just done, rather than when they mismatched what the baby had just done. So the brain is able to recognize that another social being is imitating them, and it has important neural consequences, but I think important social consequences. The social consequence is the child is looking at you doing it, and I believe registering something like, "That person's acting like me." It pops out. It's a visual pop-out event. That person's acting like me. And I think it's highly significant to the baby. Now, I want to make a theory leap here. Laura said to feel free to make leaps in this lecture. So there's several times I'm not going to give you all the connecting arguments, but just go forward to say that I think this like-me idea, that babies pre-linguistically are able to recognize the similarity between self and other, is important both for imitation and for social learning and for ideas about interpersonal connectedness, even up to empathizing with other people. That's a leap about that, but the idea that babies can recognize that you are like me and I am like you, I think provides a very primitive basis for how a sense of empathy for others could develop. It's not identical to the sophisticated adult-like empathy, but it is a substrate for developing it. And so I want to talk about that through by passing through some new research that we have done with Peter Marshall about babies' response to touch, and I want to go from their somatosensory representation of having their own body touched to how they respond to seeing somebody else's body touched, which is what relates to empathy. But let me develop this research program that has to do with not the perception of action, but how the baby's brain represents their body being touched. As you probably know, when your skin is touched, when your body is touched, that's represented in the somatosensory cortex, which is in roughly bilaterally in the central region of your brain, going down right here. And the brain is organized in what's called a somatotopic fashion, as you all know, that the body is laid out systematically from the bottom of your toes to the top of your head in your brain in somatosensory cortex, such that your hand is, roughly speaking, more lateral about here in your brain, and your foot is more central down the inner hemisphere wall, which is represented over here. So there's some separation in the neural tissue that represents the hand and represents the foot. And that gave us a wonderful opportunity to be among the first in the world to look at neural body maps in the baby's brain. The neural body map is well known in the adult brain. Penfield and others have mapped it out. That's the homunculus picture you see in the textbook. But very little is known about body representation in the infant brain. So we set out to do those studies, and I want to show you some of the findings. If you have the baby in an EEG cap, there are 3 electrodes of importance, one could say, in doing these studies. CZ overlies what you might think of as the foot area. It's the central part of the brain. And C3 and C4 are overlying, C3 and C4 are overlying the hand regions more laterally. So we touched the baby's hand and touched the baby's foot and published papers showing that there was activation in the neural regions that you would expect if the baby's brain was organized like the adult brain in this somatotopic fashion. We published a series of papers of that, and I'll give you references later. The most exciting thing is that we also showed that when babies simply saw you perform an action, the same goal-directed act of pressing this button, either with your foot or with your hand, that different parts of their brain were activated, and the part of the brain that was activated is exactly what you would predict. When babies observed you use your hand, there was more mu rhythm desynchronization. Down shows more desynchronization. They observe you use your hand, there's more desynchronization in the hand area. And when they observe you touch it with your foot, there's more desynchronization in the foot area. So when you touch the baby's skin, you can light up different regions in their brain. And when they see you use your body part and make contact with objects, that's processed by different regions in their brain. We have moved from using this technology, EEG, to using very much more expensive and sophisticated technology called magnetoencephalography, or MEG for short. And for this very expensive device, the baby sits in a helmet that has 306 sensors in it. The baby is wearing a cap with a pellet in it that allows us to keep track of where the baby's head and therefore where the baby's brain is within this helmet-like structure. And so the baby is free to move, and we can track with great precision where the neural activity is in the brain with much greater spatial precision than is allowed with EEG, and with temporal resolution that matches EEG, about 1 millisecond. So we use this. We have just recently finished a study using this MEG technology where we touch the baby's foot or touch the baby's hand with a device where compressed air comes up a tube and expands a membrane here and puts a little tap on the baby's body part. And I want to show you the brain of a 29-week-old baby. It's 29 weeks, 29 is cut off here. I'm going to show you the picture of a 29-week-old baby when they're touching their hand. And this is really first in the world film of what happens. The hand region, you'll remember, is right around here. It's laterally. Foot region is, I'll show you, in the inner hemisphere wall, but hand region is around here. I want to show you a film here what happens when you touch the baby's hand region, and I'm starting the film now. 29-week-old baby. Boom. So you can see that the neural tissue that represents hands is activated when we touch a 29-week-old baby's hand. And now that's the activation of the hand. I'm rotating the brain around so that you can see the foot area. And the foot area is around here. You remember the homunculus I showed you down the middle of the brain. And now foot should light up around here. We touch the baby's foot, and there's activity in the foot region. So this is very exciting for us because we are able, using MEG, to be able to carefully map that there's a differentiation, different neural tissue for representing the baby's foot and representing the baby's hand. And we can map where they are in the baby's brain. That's why we're calling it neural body maps, and we're trying to map out all the different, or many different regions of the baby's body. And they're really interesting predictions that can be made. For instance, one might be very interested, and I was talking to Lorna about this afternoon, one might be very interested in the role of experience in representing these body parts in the brain and how it might lead to a stronger, better, or magnified representation of the infant, of the body part in the infant's brain if they use those body parts a lot. So if you think of signing deaf individuals use their hands to communicate more to others than hearing individuals do. No one in the world yet knows about the baby's body map in ASL using infants. And we might make predictions that they have a stronger or more detailed body map than hearing infants. These are novel predictions that come out from doing these studies. From a social, emotional point of view, the things that we're interested in is, now that we know something about where the baby's foot region is and the baby's hand region is in the MEG, for the very first time we're showing the baby watching somebody's hand being touched, watching their hand being touched. And the preliminary evidence we have is that when you touch their hand, you see the hand area activate. When you touch their foot, you see the foot area activate. And so the baby is processing in their brain, in their hand region, when they see your hand being touched. Now, I think that's important for imitation because when we do something with our hands, babies imitate with their hands. They don't just try any body part. As soon as you do something with your hand, they know to use that body part. But I think it's relevant to this audience interested in ASL as well, because it surely has occurred to many people here that very, very young babies are paying very careful attention to each of the digits you used, your hand postures, your hand positions in space. And why are they, when you show a sign, why do they know to move that body part rather than do something with their foot? You know, they're doing it right here. And this is the neural representation of this wonderful organ that they're using for sign language. So I think they are recognizing my hand is like your hand, my finger is like your finger, and we can look at the neural map of that. So I got there from imitation, but I think it's completely relevant to what people in this audience are doing, and I think it's relevant then to the social consequences of that. So Peter and I and Joni Saby and Peter and I have published a series of papers. This is a new one in neuroimage, and this one is a theoretical paper in Trends in Cognitive Science that was about the sense of touch and babies' body maps in the infant brain, and those are things that we've recently developed. So now I want to move to gaze following. Gaze following is highly important for young children. It's important for language acquisition. It's important for social development. Because information is not distributed equally in the world, there are what I call in these publications information hotspots. There are places in the world that are loaded with information, and parents want to attract their baby's attention to those information hotspots. What can they use to attract the baby's attention there? And one of the things they can do is look at that hotspot. I can look over here, and everybody in this room will know what I'm looking at. If I look over here, people are wondering, why am I looking at Laura right now? You can read my eye gaze and where I'm looking very well. You project out from my eyes where it intersects with an object in space. When do babies begin to do that? It's a very efficient learning mechanism. So many people study gaze following around the world. We do it in our lab too. We have a paradigm where we have two inanimate objects equidistant from an adult and a child, and the adult and child make face-to-face contact. The objects are inanimate objects. They don't move. They're just out there in space, and then the adult turns to look at an object, and we find that 12-month-olds readily look out to the object where the baby, where the adult had looked. And we have rates of responding in typically developing children. Obviously, the adult looks to the left, they look to the right, there's a random schedule, and we're able to show, statistically, that the babies turn to follow the adult line of regard. I talked about the social consequences of it for language learning and so forth. The exciting new thing that I just got the data on essentially while on the airplane coming here is we did this study very, very recently. We haven't published it yet. with deaf children as well, deaf children of deaf parents, and compared them to a group of hearing children of hearing parents, where the prediction is that deaf children may be better than hearing children. And the idea is that deaf children are raised in a culture and an environment, deaf children of deaf parents, where they're not hearing things in the world to attract their attention, but parents who deeply want to direct the kids' attention around, when they look at a place in the world, if the child follows that line of regard, the child is getting to what the mother or father wants them to look at. So rather than using linguistic and verbal instructions to do that, or having a loud sound out in the environment, the parent can look at an object. And I know that deaf children have expanded perception of things in the periphery that are moving, but it's important that the adult and the child are just sitting face to face, and then the adult is turning to bring attention to the periphery. It's not that something in the periphery is moving. So the new data that we have show that, these are the data that show that the children who are deaf have between 8 and 20 months of age. We had children, for every deaf child, there were 5 hearing children matched to that child in terms of within 7 days, plus or minus of 7 days of the deaf child's birthday. So they were age-matched controls, very carefully age-matched controls. So we're very happy to see and very strong effect of the deaf kids being better at gaze following between 8 and 20 months of age, and it's really, really a whopping effect. We've tested hundreds of typically developing children, and the deaf children are just way out in the scale of being much better. So this is an interesting case of where children can be advanced in using visual modalities to understand sort of the referential aspect of gaze. Person looks here and they're referring to something out in space, and the little deaf children are catching on to that faster than hearing children. So we're going to continue to work with this, and studies in the seminar that we have this afternoon, a possible follow-up study was suggested that we can talk about in the discussion. So now I want to take this to show you how we use it. We have been studying in hearing children, at what age do they pay attention, not just to the fact that your head is turning, but that it's your eyes specifically that are focused on the object. So we had an adult turn to peripheral objects either with eyes open or with eyes closed. And if children are paying attention to very detailed information, they should only turn to follow the line of regard when a person is turning with their eyes open rather than their eyes closed, because when they're turning with their eyes closed, it's a body movement, but they're not perceiving the external world. They're simply making a body movement, but not having perceptual contact. So we did studies, this is with our hearing children, we did studies where we had adult turned with eyes open or eyes closed at 3 different ages, and each of these ages, children turned significantly more when the adult turned with eyes open versus eyes closed. And then we said to ourselves, well, closing your eyes is not the only way of blocking perceptual contact with the external world. You can also block perceptual contact by having an inanimate object come between your eyes and the object. So we began using blindfolds, and we had an adult turn with a blindfold to an external object. And we found that the 14 and 18-month-olds did not follow that line of regard, just like they did not follow when the adult had the eyes closed. But 12-month-olds made the mistake. 12-month-olds, when an adult turned with a blindfold, would follow where they turned, whereas they would not follow where they turned when the adult had their eyes closed. So what's the difference between an adult turning with the eyes closed versus turning with a blindfold on? And that's where I reached back to my like-me hypothesis, and I thought, very speculative hypothesis, which I'll show you how we tested in a second, I thought that babies have a lot of experience with opening and closing their own eyes, and the fact, self-experience, and the fact that when you close your own eyes, you cut off your perception of the world. And you have agency of it, you have complete self-control. When you do it, it cuts off your perception of the world, and it always works. If the baby's sitting in the crib doing an experiment, every time they close their eyes and try to see anything in the world is cut off. I thought that that self-experience might be teaching infants something about body movements and their perceptual effects. If you close your eyes, you can't see the world. That's what happens with me. When the other person does that behavior, perhaps they can't see the world. What that predicts, and that's this like me hypothesis, infants make generalization from their own actions to other people's actions. When others act like me, they have inner states like perceptual consequences like me. So we did a study seeing if we could teach the baby that adults cannot see the external world when they have a blindfold on, right? And so the way we did that is we gave the baby self-experience with a blindfold. They had objects out on the table, and for 7 minutes, every time the baby looked at an object, we put a blindfold up in front of their eyes so they couldn't see it, took it down, had other objects on the table, blocked their view, and so forth. So babies had an experimental treatment. They were randomly assigned to that treatment versus controls, where they had experienced that when this blindfold comes in front of their eyes, they cannot see the external world. And the results showed that we had 3 groups. I won't go through that. After the baby had the self-experience, the adult wore the blindfold and looked to the external world. And just as predicted, when babies had self-experience that they couldn't see the external world, now when the adult turned with the blindfold on, the babies did not follow their line of regard. So I am arguing that babies use their self-experience that I can't see when I have a blindfold on to interpret when another person has a blindfold, that person cannot see either. It's like me hypothesis. So I want to go on here to say what sort of entities have perception. Adults have perception. We follow the line of regard of adults. What happens if you have, what happens if you have an inanimate object? So we had this robot. We had the robot, which looked like this, had eye spots for eyes. When the robot turned to the side, what we found is that 18-month-old babies would not follow the line of regard of the robot. They looked at the movement. They saw that this hunk of metal was moving, but they didn't project out in space to look at where it was pointed. The objects, if you remember our paradigm, were quite some distance away. So babies, if they just followed the movement here, didn't catch sight of the objects. The objects were farther away in space. So we began to wonder what we could do to make this robot be a sentient, perceiving being to an infant. And because I think infants can understand imitation, we began to use imitation, and we had that robot and the adult interact and imitate each other while the baby watched. The baby wasn't involved, the baby simply watched. And that's what this next movie is. The baby was watching this just like you are.
Can you do this? Oh, yeah.
So the baby watched that interaction where the adult and the robot had a sensible imitative interaction, which can only happen if they're perceiving each other. And then the baby and the robot were face to face. The robot turned its head to one of the objects, and the 18-month-old followed a line of regard. So we had assigned babies to an experimental treatment where they watched imitation or other control conditions, one where the robot did the same thing but out of sync with what the adult was doing. Another ones were baseline conditions. And it is the condition in which the baby watches the interaction, the imitative interaction, that they're able to get the idea that that robot has some intentionality, perception, sense of, some sort of psychological basis and will follow its line of regard. So to skip forward, keep on going here rapidly, I want to now talk about emotions and learning. Children don't just imitate everything. They don't learn everything. They also pay attention to the emotional responses that adults show. And most of the studies that I talked about before were studies of dyadic interaction where an adult was showing something directly to the baby, And our idea was that sometimes babies learn things by watching other people interact, not only when an adult is teaching them something directly. In other words, babies can learn by eavesdropping, by watching other people's interaction. See what I mean? It's not that you have to directly, didactically teach kids everything. They can watch older siblings interact with each other and learn something from that. They can watch mother and father at the dinner table, and they observe and learn from that. So we wanted to do some studies on that, and this series of studies here is what we call emotional eavesdropping paradigm, where the setup was, let's see if I have that on the next slide. The setup is there's three people. There's an adult that shows a baby what to do, uses a stick to press a button. And we know from control conditions, if you give the baby the stick and the button, the baby will imitate it. So that's the first person. There's the adult. Then there's an infant who watched the adult. But the key person is this third person, this emoter. And the emoter's on the side. And when the adult presses the button with a stick, the emoter gets very angry at that adult, as if it's a forbidden action, and says in a very nasty tone of voice, that's irritating, that's really annoying, and makes a negative facial expression and says in a harsh tone of voice, that's really annoying. But the adult does that, the emoter does that to the adult. And the little 15-month-old or 18-month-olds, we've tested both, the little baby watches wide-eyed as one adult gets angry at the other adult for doing this action. And then we gave the object to the baby. I want to see what the baby would learn from observing that. So let me just show you this interaction first. The adult, you'll see the negative facial expression at that time that the adult is making a negative facial expression. She's getting angry, okay? And her name is Nina. She walks in here halfway through this film. So first the adult, the emoter will sit here. The adult is just showing the action to the little baby. And the baby is watching.
There.
I don't know where the sound is. And then Nina walks in the room.
Hi there, I'm going to sit here and read a magazine.
Okay. That's Nina. Nina's going to sit
There's
reading
supposed
the
to be
magazine.
sound, but I guess doesn't make much difference. And Nina is going to look up and get angry.
That's aggravating. That's so annoying.
Oh, I thought it
So
was
she's
really
getting
interesting.
angry at this
Well,
adult.
that's just your opinion. It's aggravating.
And now we're going to give this toy to the baby and watch what the baby does. Whoops. So the baby won't do the action. So Nina is over there now with a neutral face. Nina is no longer angry, but the baby is looking at Nina and will not perform the action in front of the previously angry person when the previous angry person is looking at them. Again, I think that's like me idea, that the baby is thinking that emoter got angry at the adult for doing the action. Now that emoter is going to get angry at me if I were to do that action, so I'm inhibiting my behavior. So we did several follow-up studies to make sure it was that sort of triangulation that the baby was using. There is an easier hypothesis, and the easier hypothesis is maybe the baby just saw that the adult was angry and then was frozen in their action, wouldn't do any action because there was anger present. And the way we tested that is that the adult showed the same action. Nina, the emoter, got just as angry, but then after Nina got angry, she got up and left the room. She just left. And when we gave the object to the baby looked to see that Nina was out of the room, picked up the stick and did the action. And the reason that's relevant is that Nina had demonstrated the same anger. So it wasn't just that there was anger in the room. We did other tests where Nina got angry, and after she was angry, she turned her back so she couldn't watch the baby. And as long as she had her back turned, the baby would do the action. Or Nina closed her eyes after being angry, and then the baby would do the action because Nina couldn't see her. So the baby really was doing something fairly sophisticated. The baby didn't inhibit the action all the time. It's not that the baby was scared at the anger. The baby was weighing several things. The baby was recognizing Nina got angry at this action, and now Nina, the previously angry person, is watching me. I better not do the action now. But I can do it if Nina's not watching me. So that's a very interesting combination of recognizing a person's emotions and whether that person is looking at me. It's combining gaze following, direction of gaze, and emotions. There's also another interesting characteristic of this, and that is that we did some studies to see if the baby was developing some notion of a trait about this person, and we think they are. We think the baby is beginning to represent this person as an anger-prone person, and that's very relevant for clinical psychology. So your parent might get angry at you a lot, or you might meet a person who gets angry a lot. Does the baby begin to typecast or pigeonhole that adult? So the way we tested that is we had Nina become angry when the adult did an action on one toy, second toy, and third toy. But then the adult picked up a completely new toy and did an action on it, and the emoter did not get angry at that. So she had a history of being angry, but she wasn't angry, was not angry now. And if that emoter who had been angry and was not angry now, never showed any anger at this new action, if that emoter was watching the baby didn't dare do the action. If that emoter turned her back or was out of the room, the baby was happy to do the action. So we think that the baby is representing the adult's emotional history. You see what I mean? The adult wasn't angry now at this act, but that adult is an angry-prone person. And we all stereotype or pigeonhole adults that we interact with. We believe they have certain traits. Laura's a friendly person, right? So when I see her in a new context, I attribute some characteristics to her that I learned about her in the past, and I can make predictive generalizations of how she will act in this new context because I have a representation of her past emotional characteristics. She's a generous person. She's a friendly person. Very important to the baby, maybe, is this pigeonholing that this is an angry-prone person. I better not learn from this person. I better not act in front of this person. I better be careful in front of this person. So we think this is important for social psychology, what's called trait attribution, that little 15-month-old babies are beginning to form representations about the personality of the person they interact with. And we think that that's relevant. So these new papers from 2016 just published are about infants' generalization about other people's emotions, foundations for trait-like attributions, attributing traits to other people. It's relevant to bilingualism, trying to remember you speak Spanish to that person, you speak English to this person. This is an angry-prone person. This is a playful person. Little babies are beginning to make those generalizations. Okay, so this is a part that I wanted to get to, which is why I'm moving quickly through the rest of them. I think Laura told me that this lecture series had to do with breaking down barriers, right? And Laura and I had breakfast this morning, and she was talking to me about how differences are not necessarily deviance, they're just differences. And stereotypes are relevant to this, and I want to bring stereotypes and children's awareness of people and the stereotypes that culture attributes to others. So here's the idea. American society, and clearly societies all over the world, have stereotypes about other people. In America, there is a very strong stereotype related to gender that's very well spread, widely held. I know it's not a truth, it's a stereotype, and the stereotype is that girls don't do math. Boys do math, physics, engineering, STEM topics. Females do not do that. People are aware of that stereotype. Don't shoot the messenger. It's not my belief. It's a stereotype, right? Because I'm interested in children learning social categories from observing others, and because I'm interested in them mapping what to themselves, I began to wonder, when do children begin to catch the stereotypes that other people exhibit in the culture? So we tested, to begin with, elementary school children to test their stereotypes about girls and math. Now, there are other stereotypes to test. In American society, there's stereotypes about race, there's stereotypes about age, about SES, about disabilities, about many different things. But in this particular experiment, we want to study children's stereotypes about gender, and especially about gender in math. And so we developed a test to look at that, about here boys do math and girls do reading, and we did it through explicit tests, but we also by asking kids questions about who does math and who does reading. But one of the things we also did is to develop a child implicit association test, or child IAT. How many people nodding their heads about what an IAT is? It's a way of IAT. It's a way of looking at children's implicit representations of the world. And it has to do with speed of responding when you see a stereotyped association, such as boys and math. You're faster when you see boys and math associated together to push a button than you are when you see girls and math, right? The stereotype association is boys and math, girls and reading. And if I show you those, you are very fast to respond. So we developed a child version of an IAT test, and we're able to test kids from 1st through 5th grade. And the stunning result is that as early as second grade, before their kids learn their multiplication tables, Seattle kids were highly stereotyped that boys went with math, boys went with number, boys went with graph, girls went with reading, book, letter. Second grade, before the multiplication tables, they were highly stereotyped. So they had caught the stereotypes that exist in the culture and began to assimilate them, and I believe applied them to the like-me category. I'm a girl. I look out in the world and I'm very attuned to and pay special perceptual attention to. If I'm a girl, how does society treat like-me others? How does society treat other girls in this society? And when you look around in American society, there's all kinds of things in magazines and in media, teachers, parents, that girls don't do math. That's the stereotype. So we believe girls have gender identity. I'm a girl. They look out there, girls don't do math, and it changes their self-concept. I don't do math. And this is shown here. There's a distinction between these three constructs that if you keep them straight, you can look at the developmental pathway for each of three constructs, and it develops in the order, we believe, that I just articulated. The relation between self and boy is gender identity. The relation between a social category like boy and an attribute like math is a stereotype. Boys don't have to go with math, but it is stereotyped that that social category goes with this attribute. And the link between self and math is a self-concept. And we think that those things develop in order, which we've articulated in these various publications, that early on, we and many other people think gender identity develops early in late infancy or early preschool period. Girls recognize I'm a girl or I'm a boy. And then by second grade, they've caught the stereotype that girls don't do math And then a little later in development, perhaps by 3rd grade, they internalize that stereotype that I don't do math. See what I mean? They catch it from the culture. So we're interested in children's kind of reaction to stereotypes that adults have. And we think this is incredibly important for their self-concepts and what their aspirations for the future are, because our children are watching how we treat others in society. We've just published a paper that's online right now about kids catching social bias. And that's an interesting paper in Psych Science, and what we had there were 2 adults on videotapes side by side, and then 1 adult in the middle, and an adult in the middle would turn to one of what we call the targets, 2 adults on either side, and turn to one target and act in a very prejudicial, biased way, and turn to the other one and act in a very positive way. And then we presented these 2 adults to the children, and we simply said to them, who do you like more? Who do you want to learn from? We had them do an imitation task where they had to imitate what this adult were doing and that adult was doing. And the general idea is they said they didn't like as much the person that they observed the adult act negatively to. They were less likely to imitate that adult and so forth. Less likely to learn a language, a word, a label from that adult. Does that make sense? So we're beginning to look here about the mechanisms of intergenerational transfer of bias. How the children, these tender little children, learn prejudice and bias. And one way they do is, again, not because we explicitly teach them, not because we reward them for acting in a certain way, but because they're observing our behavior and they want to be like us. They adopt our stereotypes, they adopt our biases. So that gets us me to the conclusions, and I'm running out of time here, so I'll just say a few slides. How can we advance theory? Well, one is to explore the body map. What is the baby's brain? How did the baby have represented hands, feet, lips, trunk, other parts of the body? What about the representation of the body map in newborn babies before they've manipulated the world? What about special populations, such as deaf children who early in development probably, we don't have data on this, but probably pay more attention to their hands and fingers and the positions intentionally than hearing infants do, right? And so the neural representations of these gorgeous organs could be more adult-like in a deaf infant early on than it is in a hearing infant. That was Lorna and I were talking about that sort of study earlier today. It seems very relevant. We want to analyze infant representation of action. I think that imitation is not one indissociable unit, but be broken apart into the body part you use, hands or feet, the actions you do, and the causal consequences it has in the world, so we can begin to analyze imitation and its neural representation more carefully. And I think it's relevant that imitation connects down to action science and what I'd say is up to social cognition and theory of mind. This like-me recognition that first happens on an action basis is what I think is development for a lot of later social cognition. So the developmental theory idea is there is a starting state of action representation where there's a basic connection between the perception and production of simple acts. And I think that connection, that mapping between perception and production is demonstrated in neonatal imitation and other phenomena. I think another phase, the next phase, is infant self-experience. Infants begin to recognize that when they are acting in a certain way, they feel a certain way. And by having that connection between their behavior and their underlying inner states, whether it's their behavior and their perceptions or their own behavior and their emotions, I think babies are able to make that connection between behavior and underlying mental states in themselves, and they use that experience for understanding others. Those people who act like me have mental states like me, and I've tried to develop that like me idea in these series of papers. I want to emphasize that I don't think self-experience is the only way that infants learn the relation between behavior and underlying mental states. I think they can get there by looking at the structured, orderly behavior of other people too, and I've published some papers about that, but I wanted to develop this developmental progression right now. And the perhaps last slide here is this idea of developmental phases at a broader level that gets to breaking down barriers. I think infants imitate a person's actions, their motor behavior, but they're analyzing that person in terms of motor acts. At a slightly older age, toddlers and elementary school age, they're paying attention to other people out there that are like me, and they pay attention to how society treats those like me categories, and that's what picking up stereotypes are like, and they begin to not just identify with another person through action, but to pay attention that how culture treats others like me has implications for myself, how I can think of myself, what I can aspire to dream about, and it affects their self-concepts. And I think that's very important. They've now moved beyond recognizing the similarity at the level of pure action to social categories as a whole and what group they belong to and how others treat that social group. So I think the last slide in here is a paper we published that was emphasizing the importance of brain perception action coding and how that filters up to the kinds of things I was talking about here to more important and larger categories about social groups, stereotypes, and the like. And we call that Foundations for a New Science of Learning, because although there is a very rich initial state that I think infants start with, that initial state gives them a framework for interpreting the actions of others and the way they're treated, and helps, has cascading effects in them developing social cognition. So I think with that, that's the end, and I'll take questions. Thank you.
Okay, thank you very much. It was a wonderful talk. I'm sure someone in the audience have questions. Please come forward. Make sure to come here where we can all see you. I will leave the mic on the stand here. Thank you.
Hi, it's nice to meet you. I noticed a number of things, fascinating research. One thing that came up for me is I do a lot of diagnostic work with kids with autism, and I see tremendous potential for children with autism, assuming that they have the social cognition, the delays in theory of mind, and there's research, Amy Klin from the Yale Child Development Center, he's now in Georgia, I believe, did a lot of eye tracking research about children who have autism, and within a few weeks, infants you can see they're not paying attention to the right things. So this, to me, it would be amazing. I mean, you'd have to test it empirically, I guess, but to know whether or not you would expect that children who have autism would not do well on these tasks. And we're still not diagnosing autism until kids are 3, 4, 5 years old, sometimes even later for kids who are deaf. So I'm wondering what your thoughts are about using some of these tools as a diagnostic tool.
Yeah, I think you're exactly right. So I'm so happy that you've made that connection. I think it's incredibly important. And actually, if you go to my website, you'll see that I have collaborated on several studies on children with autism with a person named Geraldine Dawson, who was at the University of Washington. Then she became CEO at Autism Speaks. And we have done some of these studies of of imitation and gaze following, and others in children with autism, and even SIBs of children with autism. So some of those studies are published. I think it's a great example of what everybody here knows, that there's differentiations that can be made between different populations that are based on theory and what you'd expect. So children with autism are delayed in intention reading, joint visual attention, imitation, and other aspects of social cognition. We haven't tested things about somatosensory representation and body representation in children of autism yet, although that's something we want to get to because those studies are fairly new. But I would think that there would be deficits in this like-me mechanism of recognizing the similarity between self and other. And that may be a fundamental issue in the development of autism. But at the same time, we found that, to make a big leap here, we found that deaf children of deaf parents were advanced in something like gaze following, right? And so one would want to go through many different groups and make predictions about how hearing infants of deaf parents respond to various tests, deaf parents of deaf infants, and so forth. There's many subtle tests with, I think, differentiable predictions. And I think, whose seminar was your seminar that we were talking about that today? And I think you were raising those issues about looking at different populations and what sort of fine-grained predictions could be made. And I think that really is one of the advantages of being able to do work on behavior and on brain, and with many different populations with the theory to make predictions, we could make some progress that we've been longing to make for some time here.
That was a great talk, thank you. So you had these amazing new results that you just got while you were on the plane, showing that deaf babies of deaf parents have better gaze following. In a separate part of the presentation, you talked about gaze following related to emotion recognition. Mm-hmm. Would you speculate, or do you know whether there's evidence speaking to whether deaf babies of deaf parents also have better emotional recognition, or any differences in sort of emotional responsiveness to others?
No, that's a great question. I think that kind of research is exactly the kind of research that one want to do based on the new finding on the basic level of gaze following. So our emotional recognition paradigm sort of combines not just recognition of emotion, but combining another person's emotion with whether they're looking at you now. That's what our paradigm is. So we had to do the first study first about whether deaf children were good or not good at gaze following. Now we know they're better, and so your hypothesis might be that they're more advanced on some other aspects of social cognition as well. And we just simply don't know that at the moment, but you're probably aware that people have studied deaf children and made some claims about theory of mind development as measured with false belief. And so combining new measures of social cognition with those existing studies is something I think needs to be done.
Sounds like there's a lot of research we need to do.
Yeah.
Thank you very much for a wonderful talk. My question is, how does this compare with the statistical learning for categorization that children use for other things, including language and phonology and so on and so forth?
Right. No, that's statistical learning done by Dick Aslan, Alyssa Newport. the connection to statistical learning, I think, is quite relevant. Usually statistical learning is thought of as detections of patterns, often but not always, having to do with segmentation connected to time. Imitation of body actions is not really a phenomenon of statistical learning as such. It's a mapping between body movements they see onto their own body. So it's not a problem of statistical learning from that point of view. However, you may be making a leap that I think is related to the trait attribution studies that we've just done, which is if a child sees an adult get angry 3 times in a row, it's as if, to use your language or to allow us to be speculative here, it's as if they're picking up that pattern, that statistical connection between emotion and that person. That person tends to get angry. So now when they see that person manipulate a completely novel toy, or they see another person manipulate a novel toy and the emoter does not get angry at it, even though the adult doesn't get angry, they now have the statistics that the adult had been angry at an action 3 times in a row. Now they hadn't been angry. Chances are, however, that this is an angry personality. So I think you're right that statistical learning comes in the formation of stereotypes and the formation of making trait attributions to others and bringing that literature together so you have sort of social statistical learning of likely behavioral reactions, statistical learning of personality traits of a person. I think we could begin to use the term to explore that, and that would be quite interesting.
And then when the older infants as well, what were their backgrounds? Were their parents hearing, deaf? What variables, demographic variables, did their parents represent for the deaf and hearing kids?
In which population did the deaf, which study?
Any of the studies, any of the infant studies that you've done.
So these are, in general, the studies are done in children who come into the lab at the University of Washington. And so they're upper middle class families who have a car and can drive to the University of Washington. But there's 2 sets of studies that I think might be of interest to you that go beyond that. The first was the study that we did with deaf children of deaf parents. We tested 12 such children, and we had to go across the country and flew to many different places to recruit and test such children. So what I wasn't able to present here is full demographic data of those children, but in the publication we'll try to include that. And Melissa, where's Melissa here? Helped us recruit some of the children for that study. I hope you saw on the bottom of the slide it was done with Jenny Singleton, who was connected to VL2, and Tom over there provided some funding through Science of Learning for this study. So this was a good example of 2 Science of Learning centers coming together. The other author of the study is Rochelle Brooks, who does joint visual attention with me at the University of Washington. So the full demographics of that study and the level of ASL proficiency of the parents and all is an important characteristic for that study, and I was just reporting, the main effects here, so we will be including that. But if you're interested in variations across different groups, in the stereotype work, we're now doing 2 different countries, and one of them, actually 3 different countries. One was in Singapore. I'll mention that first. Singapore, the children, boys and girls, both outperform American boys and girls in math, outperform them. But Singapore is also interesting because the girls on standardized tests in the elementary school are either equal to or better than the boys. So it's a culture where the girls do better than the boys. And the stereotypes of the adults in the culture are not as severe as American stereotypes of boys do math and girls don't. In Singapore, that stereotype is not as prevalent or not as strong. So we are extremely interested in and finished a series of studies with Singaporean children. And in fact, we find, although there is a stereotype in Singaporean children, it's delayed and weaker than in American children. So the stereotype held by the kids does seem to be picked up by the culture and is malleable and pushed around by the adult stereotype. We also tested kids recently, and I don't have the full set of results, in a highly stereotyped culture, the opposite direction of Singapore, and that was in Chile, where there's quite a strong stereotype that boys do math and girls don't. So, and I don't have the full set of results from the Chilean study yet. But so that's an example where we are trying to pick cultures to test the theory where we believe it is going to be that the children's idea of the social world and social groups is going to be caught from the adults in the culture, and we believe that's going to be an important message not only for theory but for policymakers and education, that the children are watching us and how the children are called upon in the classroom, how the teachers treat the children, how the parents and grandparents treat the children is going to affect the children's stereotypes and eventually their sense of self.
Thank you. I stayed because I have a follow-up question. Have you done any experiments on children who have deaf parents that are both deaf and hearing? So deaf kids with deaf parents and hearing kids with hearing parents. So have you done a study with children like that?
Well, we've done deaf children of deaf parents, hearing children of hearing parents. What we haven't done is hearing children of deaf parents, and that was raised in a seminar today about interesting populations of deaf.
I was thinking about having both deaf and hearing kids who have the actual same parents, so like siblings, families where they have deaf parents and they have both deaf and hearing children in the single family.
Right. Well, it's difficult to find these populations. We just finished our first study, but I agree with you now that there's a paradigm. If there are people here at Gallaudet that would like to collaborate on helping to find a range of other populations to do some of these tests of social cognition, I think from a theory point of view, one could make fairly fine-grained predictions, and at the seminars that we had this afternoon, I think some of the participants began to outline particular predictions like you were beginning to outline here, and I think it would be fascinating and important to do. Yeah.
Thank you.
I have one other thing.
I wanted to give occasion to two more questions,
Yeah.
and then we will close. I
Yeah.
see the Professor Steele and Professor Rashak here. Which one wants to go first? After the second question from the professor, we will have our opening remarks. We are on.
Okay.
Well, I understand my question here, but maybe before I'm going to try to learn. Like me makes great scientific sense for those who recognize the evolution of survival. Because I am like my parents, I have this genetic need to mirror them, to become them in my life. And I'm sure in the seminars this afternoon this topic was discussed, but we have students from speech, language, and hearing who are asking, how do we make sense of parents who are not like their babies, parents who are themselves hearing, who give birth to a child and maybe by day 5 know that this baby is not like me. This baby is not going to sing like me or talk like me or play a musical instrument like me. What would you comment for these students who are wondering, why don't these parents just automatically have a desire to acquire sign language and become fluent signers for their babies?
Well, that's a profound question. On the one hand, it maybe shows the power of like me and grouping and recognizing other human beings and having a real being impelled to make that comparison. Now, that comparison has good consequences and bad consequences. The stereotypes, the idea of social grouping and separating people into like me and not like me, us and them, is a bad consequence of the idea that human beings seem so compelled to do this mapping and hunt out for others that are like me. I do think, though, that many people are able to have a wider circle of what counts as like me, being human like me, having emotions like me, having a more fundamental sense of what it means to be like me, not just, say, to dress like me or have red hair like me or blue eyes like me. So there are other features that one could think of as more superficial, not the essence of what it means, not the essence of humanity. And so I think there's a drive to separate us and them, but there's the ability perhaps to teach our children and raise our children with values that allow them to widen the circle and include a greater aspect of humanity as being like myself and different than other things in the world. And there's actually cultures that draw the line beyond humanness, and all animals are like me, right? And we should not do harm to any living things. Do you see what I mean? So what you count and what dimensions you use as the like-me-ness, I think partly can be moved by acculturation and the values of the parents and the values of the society you're raised in. The thing that I think infants start with as a dimension of like me is body action, which does pick out the universe of human beings that either have morphology like me or move like me, and that's a pretty broad class.
Thank you. It's getting very late, so I'll be very brief. You talked about the role of reward early on in your talk. And if I understood you correctly, you were saying the reward doesn't play much of a role in imitation learning, and you were saying, giving the example of the parents actually telling off their children to do something, they did it anyway. On the other hand, you were showing all these lovely movies of how happy the children were when they accomplished something. They were able to actually do the job and imitate something. Yeah. And the smile alone tells me that their reward center in their brain was lighting up, and they were sort of enjoying this, certainly. And doesn't this constitute some kind of internal reward that they get maybe much stronger than the reaction of the parents? Or maybe the parents also sometimes do react unconsciously in a very affirmative way, and that could constitute a form of reward.
Yes, I think that there are those two, there's many senses of reward, but you just articulated two of them that I deeply endorse. So the child seems to have an intrinsic sense of reward from being like the other or accomplishing their goal or acting like the other person acted. So the adult put beads in the cup, and then the children duplicated it and became happy. That was not, so you're absolutely right. The child felt a sense of reward, an intrinsic sense of reward. I'm not saying that reward is differentiated from and has no role in imitation. The question is the source of the reward. So the child was intrinsically rewarded for acting like the other person or achieving the goal that they saw the other person achieve. What I was trying to say is that intrinsic motivation does drive children to imitate more than, or they do it even in the absence of, the adult rewarding them from doing it. It's not that the baby sees the adult do something and then the baby reacts randomly and the adult has to shape the baby in order for that random movement to become a duplication of what the adult did, right? Then you'd be using reward to shape the baby to imitate. What I'm claiming is that the baby can see you perform actions, map it onto their own body, and when they do what they see you do, they have an intrinsic reward or positive feeling from having done it. And I think you're right for articulating those two distinctions. I think it's theoretically of deep interest that the child would feel good and feel pleasure from having reached the goal that they see you reach, or act like they see you act. That's a big impetus for social development if a human being feels that way.
The big mystery is obviously, as you also pointed out, and so provided an answer for to some extent in your classical early experiments, that some of this behavior is even innate. But nevertheless, I think it's still a mystery how the child learns how to access the right body part when they imitate a certain form of behavior. And I think that's where the plasticity comes in, and where the learning and the reward learning also might help, to wire up the synapses with each other that belong together.
The word learning?
Reward learning is all that. That's where the purpose of this intrinsic reward, as you just called it, might play a role.
Right. Well, I think there's innate state that is transformed through experience, and how that experience, whether it's self-experience or continuing to perceive the actions of others, how that changes the infant's internal structure, I think, is deeply important. So experience does reach in and change those initial representations. They are altered from the baby using their own body and watching other people use the body. And looking at that process of development is, what developmental science needs to do. How does the behavior, how's the behavior change the brain, and how does the brain maturation and changes affect the baby's motor behavior? That sort of interchange is deeply important.
Okay, so let me make 3 brief comments. First, there's a questionnaire I'd hope everyone is willing to fill out. I'll pass out more copies if you don't have yours. Second, thank you to everyone, and thank you to our colleagues from neighboring universities that came here for this lecture. And third, I'm sure a lot of you have questions and comments. Well, we have a wonderful little reception waiting for us, so we're going to whisk Professor Meltzoff away and join us. Please come and talk a little more, express your ideas. We're really happy to have you here. It's in the SLCC. Okay? And anyway, follow us.